Hey everyone, thanks for having me here. Really excited to kick things off. My name is Prakhar, and today I'm going to talk about how we can use Firebase to build an app from scratch. So building an app from scratch, for those you've attempted, right, is often daunting. There's so many moving parts and factors to consider. And with Firebase, you'll have many different products to help you and run successful apps, regardless of the platform you're using. So in this talk, we're going to learn about how various products such as authentication, Firestore, storage, functions, machine learning, hosting, cloud messaging can support building a new app with ease and abstract away infrastructure management to allow focusing on users. Here's a quick slide about me. Thanks for the introduction. Like it was said, my name is Prakhar. I'm a software engineer at Google and Firebase. I'm a full stack engineer with a background in machine learning and AI. I'm also passionate about open source. I love contributing on open source projects. Here's a random fact. Three things I love is Vim, which is my favorite text editor. I love compilers. And finally, my current programming language that I've been learning is Clojure, which is a Lisp style programming language on the JVM. Cool. So let's start with an idea for an app, right? And we are thinking of how to build it, but let's start with pretty common app architecture. So most apps need a database. So we have a database here. Users want to access data. So there's always some kind of an auth system. You don't want to allow everybody to access everybody's data. People should be able to access their own data. And so that's where an auth system comes in. For files, right? For big files, there's also some kind of a media server. And then there's an API server that combines all of these things together and talks to the app in a useful way. But here's the thing, our idea is a really good one, right? And then suddenly we need to think about what happens when the app grows. What happens when the app succeeds? What about new platforms? If I start on Android, what about iOS users? Is this secure? Am I making sure that users can only access their data and not somebody else's? Is my database fast enough? Will my API server scale as more and more users use my apps, use my apps? So all these are very tricky questions, or very important questions, and this is the daunting part of building an app. So with all these concerns, we might forget the reason we started building this idea in the first place, right? And if there was something that can make this easy for us, that we can start building the app and not have to worry about so many of the other issues that surround it, that'd be awesome. And that's where Firebase comes in. So what is Firebase? So Firebase is basically Google's app development platform. It's built on top of Google Cloud. And Firebase integrates with several Google tools such as analytics and ads. And of course, it's built on the Google infrastructure, so it's designed for scale. And regardless of what platform you build on, Firebase supports a lot of different client app platforms. So there are several client SDKs for iOS, for Android, for the web, for C++, for Unity, and Flutter. And even within these platforms, for example, web, there are client SDKs for Angular, there are client SDKs for React and Vue. And similarly for Android, there are client SDKs for Android Java and Kotlin. Cool. So Firebase is a set of almost 20 products, and it's intended to help you through the life cycle of developing apps, which typically goes something like this. So when you're first starting out, you'll need to build the app. And then there are products to help you do that. So there's authentication that helps you understand a user's identity and to authenticate them to your app. There's Cloud Firestore and real-time database, which are NoSQL databases. There's cloud storage to help you store big blobs of data, like photos, videos, audio content, etc. And then there's hosting, where you can host your websites. Once the app is built and deployed, you can monitor its performance using tools like Crashlytics and performance monitoring. You can fix bugs, and you can use Test Lab to test those fixes on all different kinds of devices you may not have lying around at home. And once the app is in a stable state, you may want to grow your app to attract more users and retain the users you already have. Within this, there's cloud messaging and in-app messaging, which allow you to send notifications to remind users about purchases or events. There's A/B testing to test any change before you roll out to your users, and there's remote config to help you decide what users like, in the hopes of making sure they continue to use your app and other people use it too. So these are the vast suite of products that Firebase have at every part of the app lifecycle to help you even get started, to improve the quality of your apps, and grow your app. All right. So given I've spoken so much about what already is a Firebase, let's see if we can walk through a real world app that you and I might build and see how can Firebase help us. So before we do that, let's introduce the app that we're going to build today. And the app is called the Expense Tracker app. And as a person, I really like knowing where I'm spending my money. I really want to keep track of my expenses. But what I actually do now is write them out in a spreadsheet, right? I look at my receipt. I manually enter the date, the item, the vendor, and the amount every time I spend money. And that is fine until this happens, right? I have having tons and tons of receipts from a travel that I recently did or from an outing I went to. I procrastinate, and then I don't have my expenses in the spreadsheet. And so it takes a lot of time, and it's a tedious amount of data entry that I have to do every single time. But what if we can make, or what if there was a way to make this even faster? What if I didn't have to type those things manually, right? And so instead of typing manually in the expense data, what about we can scanning the receipt to report business expenses? That will be really cool, right? I don't have to enter stuff manually. I don't have to worry about forgetting. I can just, whenever there's a receipt, I can take a photo of it, and voila, and we'll have it in the expense tracker. Okay, so that's the app that we're going to be building today. At a high level, the app takes an uploaded image receipt. It sends the extracted information to the user for verification. And that way the user has to do no manual work other than taking the picture of the receipt. Okay, so let's talk about the app flow. So the first step we want to do, first we want users to upload images, either by taking a photo through the camera or by choosing an image that they already have on their phone. Then our app needs to find and extract the text from the image. We will want to scan the receipt to pass for things like date, vendor, item brought, and the amount spent. And finally, we relay what we have found back to the user because we need them to confirm the information we've extracted. Hopefully, we did a good job with the scanning and it's accurate. If we did a bad job, then this isn't much of a confirmation step anymore. It becomes a correction step. Since the whole point of building this app was to make sure that users don't have to manually enter the data, it'll be pretty bad if the scanning was bad. Scanning was inaccurate and made the user input information anyway. Hopefully, it does not come to that. Cool. So what do we need? So diving deeper into what our app is going to look like, here are some of the needs. We want to be able to secure image uploads, securely upload the image that the user takes to the receipt. We don't want users to see each other's receipts, which have confidential data. We want to store the images, and we want to extract the text out of the image from the receipt. We want to do the image processing on those images. That's how we can extract the text. And that is what we need to build the OCR feature, which seems like a pretty complicated feature within the app, right? And all of this does not seem very trivial. And so let's talk about how we can use Firebase to not just build the OCR feature, but also build all of the other features in the app. Okay, so the first thing we said is we need a secure image upload, which means that we need users to be able to sign in. Now, I don't want to spend my precious time as a developer building an authentication system, given that it's been done so many times before. And it's probably quite tricky to get the security correct on the first try. Also, as a user of many apps myself, I know that I don't enjoy creating a new account for every single app I use. It gets repetitive to set up an account with my first name, last name, birthday, etc., etc. And then I have to remember my password, which I probably won't be able to do since, well, we supposedly use different passwords for the millions of accounts that we have, right? It'd be really nice not to create a new account for this app. So what can we do? We have Firebase authentication. Firebase Auth provides identity as a service, meaning it lets you know who your user is. It also provides a rules system to grant and deny access to resources in other Firebase products like Firestore and storage. And finally, Auth is ready to use out of the box. And it gives you advanced functionalities like email verification and account linking. Okay, regarding the concern about not wanting to create a new account, Firebase Auth works with many third-party identity providers, including Google, Facebook, Twitter, Microsoft, Yahoo, and more. And once users sign in with one of these services, we assign that a user is a record within a Firebase system. This includes a unique user ID, a signed web token, and used against Firebase services, your own custom servers, no matter how they sign in. Okay, so let's see how we can, in code, create an account to sign them, allow them to sign with username and password, log in that account information, sign in with a third-party provider in case you don't want them to create a new account and password, and check whether the user is logged in. As a side note, so in the next few slides, we'll be going through some code. Don't worry about copying the code, as all of this is going to be available on the Firebase documentation anyways. Okay, so as a quick rough mock, this is how my account and my create account and password screen is going to look like. So first, let's talk about enabling our users to create accounts via email and password. To create a user with email and password, we'd have to first make some pages for the user to access the account. Assuming the users fill in the both username and password, we can write some Firebase auth code to create an account. So we start with this method. We take the email and password from the previous screens, and we can call create user with email and password, which will result in either a successful creation of the account or it will error. If it errors, we can handle the error messages here. If it succeeds, we'll be able to see the user's new account in Firebase console. Let me show what that looks like. So Firebase console is a web portal that you can use to administer as an admin tool for Firebase. Here, you'll be able to go to the Firebase auth product, Firebase auth on the side nav, and see who the user who has logged in. You can see what provider they've used. You can see the date the account was created, and you can click the unique user ID that can identify this user throughout your app. And so here, if it succeeds, you'll be able to see the user's account. So here, if you can see testuser@gmail.com, tells us the user account. This tells us the provider, and this tells us the account date. And finally, the UUID in the app. Okay, so now that's how we would implement code to enable a user to create an account. But what if we needed them to use an already created account? Like I said earlier, it's not fun creating username passwords for every single app that we use. And so there's a way to include a third-party provider that'll be pretty useful for our users. So upon pushing the submit button, we can call sign in with email and password, and again pass in the email. So for signing in with a provider, here's how that can be done. So we first create a provider. And in this case, we're using the Google Auth provider, which allows users to sign in using their Google account. Apart from Google, Firebase also supports Facebook, Twitter, GitHub, and so on. So next, let's actually make the user authenticate. So there are two ways to do this. One is using a pop-up. And so what's shown here is signing up with a pop-up. So it takes an auth and a provider. And the function, if successful, gives back the user. And if there's an error, you can handle the error and show that to the user. And so just in a few lines of code, we now have Google Auth implemented in our app, where users can sign in using their Google account and get started with our app. Okay, so now we've talked about how the user can create an account, sign into the said account, and sign in with a third-party provider. We'll have to talk about whether the user is logged in or not, right? If as a developer in the app, we need to know whether the user is logged in or not, so that we can show the screens, we can update the UI accordingly. So whenever create user with email and password and sign in with email and password get called without an error, an on auth state change function gets triggered. If there is a user, then the user is signed in. Otherwise, no user is signed in, and the function that the email and the function got called because the user logged out. This function will return a user whenever either of these two methods get called successfully, as well as when there are any third-party providers such as Google, Facebook, Twitter, etc. are used. So once you have the user, you can get various information from the user like display name, their email, user ID, etc. Cool. So now we've talked about how users can create accounts and login, as well as how to know whether a user is logged in or not. One last tidbit, even though the code is already ready, much thanks to Firebase Auth for all these steps, it's quite a bit of work to actually make these sign-in screens, especially sign-in screens with multiple third-party sign-in buttons or a create new user screen. And that's a lot of UI work that you'll have to do. Wouldn't it be cool if there's a way where we can reuse the UI? And so thankfully, Firebase comes with the Firebase UI library, which handles all of these cases for us. It's an open source library, so you can customize it the way you'd like, the feel and the look of your app. Okay, that's great. So now we're done with the authentication. So now we've enabled user accounts. The next thing a user needs to do after the logging is uploading receipts. So let's say we have a screen to allow the user to upload their receipt, either by taking a photo of it or choosing a file that already exists. Once they do that and upload it, we need to store these somewhere. What do we want from the storage system? Right? Well, we'd like it to be fast for uploading and viewing receipts from anywhere. We want it to work well, even with spotty internet connection. And we might need to store a lot of receipts. And we don't have a team to keep an eye on the usage to adjust our storage capacity. Lastly, we may have to consider working with a variety of image types. Cloud storage for Firebase is another product which is designed exactly for these concerns in mind. It lets you store many different kinds of images. And on top of that, it can also allow you to store any kind of user-generated content, such as audio, videos, or any other files. It's generally used for storing unstructured blobs, unstructured data that you don't need to change often. It also scales automatically. Since we want to store a lot of receipts, we don't have to worry about whether the storage bucket will go out of quotas or will it run out of disk space. We don't have to worry about all of that. It handles and scales gracefully as the amount of content grows. And finally, cloud storage is really fast when accessed anywhere around the globe. Because cloud storage uses a global edge cache, which means that if I pulled up a receipt to look at it, storage will store that in a nearby cache so that if I want to see the same receipt 5 minutes later, I'll be able to see that receipt image really quickly. Sometimes the internet connection is not so great, right? And I think this is very common when you're like going through a tunnel or you're uploading a receipt where you have spotty connection, where we don't want a receipt to be half uploaded or dropped because the internet connection was spotty. Turns out Firebase storage also takes care of this and handles retrying and resuming my uploads and syncs whenever my phone gets back the internet. After my receipt is uploaded, it can be shared to other users instantly. So this means that if my friends or my parents want to look at my receipt for whatever reason, they can look at it right after I upload it. Okay, but I don't want anyone to be able to see my receipts. Ultimately, receipts, the data in the receipts is private information. They could have users' address, their credit card number, etc., and that you definitely don't want that to be available to anybody. So we can use security rules that we can set and make sure that only certain users can read or write files in cloud storage. Now let's look at the code to upload files. So here we have a file that you want to upload. Firebase storage supports files from JavaScript to blob, APIs, bytes, various string types, where we are going to store it. So storage is structured using folders and subfolders, very similar to how you would store a file on your local computer. We grab the top of the directory structure, where we call the root reference by doing get storage. And from there, we can create a child reference to the full path with the file name. This child reference will be located in the root reference, whether it's a file or a folder. In this case, we created a file. Now, with a reference, we can upload it to cloud storage by calling upload bytes, which uploads the JavaScript files, blobs, or bytes. We pass it the file reference and the information we want to store there. In this case, the file itself. And the file will then get uploaded and it'll do any post-processing needed after it does so. If you want to upload a string, then you can also use the upload string method and pass in a reference to the string we want to store. Okay, so now we have enabled users to upload receipts and put the receipts into storage. What's next? The next thing we want to do is we want to process this receipt and extract the text. But we may not be able to do all the processing on the client side. This is why, which in this case could be a phone. Why not? Well, once we write our top secret code to process the receipts, we don't want anyone to be able to take it along with the data. Requests coming in from user's phone might be trying to steal it, or we need something to help us running our code against our data securely. We want both iOS users and Android users to be able to use our app, and we may not want to duplicate the code between the receipts twice. It may be much better if we write it once and have the code run instead of writing it once on iOS, deploying it to the App Store, and again writing it for Android and deploying it to the Play Store. Also, if we deploy the app separately, iOS users may want this awesome feature first, and the Android users might get mad, and we definitely don't want that. And remember, we are looking to process our receipts. We mentioned that we'll use text recognition on the receipts, which is a pretty CPU-intensive task. Given the variety of phones that users have, in some cases, a phone might not even have the capacity to do that kind of a task. And even if it does, we don't want to drain the user's battery just because they use our app. So how about we'll have to run our OCR, the text recognition in the server. Cloud Functions for Firebase enables you to run backend code in the cloud. It's a secure environment, and you can write it once for both iOS and Android. To run the code, it can be triggered based on various platform events or an HTTP request on both platforms. And since it's running on the cloud or the user cloud and not on the user device, it would be very easy to access from the devices. Best of all, you can run backend code without managing any servers. There's no servers to log into, restart, shut down, or anything. All of this is managed directly for you. Cloud Functions automatically scale up and down to meet user demand, which means that if our app is an overnight success, Firebase can handle it. And we only pay for what we use. If we scale down to 0, we don't have to pay for anything. Cool. So now we are going to use Cloud Functions to run our processing code, but what are our functions actually going to do? Well, we need some machine learning to help us extract the numbers from the receipt. And this is a common problem called OCR, or optical character recognition. And we want to get this automatically done. But I don't know how to do machine learning. Machine learning is not a trivial task. And usually one would need a team of a data scientist or an ML expert to build and train models. And in order to serve those models dynamically, we'd have to build the infrastructure to do that. And that's before we even start writing the client code to interact with the model and generate predictions. This sounds like a really involved and long task, which we might not be able to handle ourselves. So instead of building our own models, we can use Firebase machine learning to help us. What is Firebase machine learning? Firebase machine learning uses Google's best machine learning models to help with different ML capabilities, depending on the features you're looking to add to your app. It can recognize text or barcodes from an image, translate text to a different language, or identify important objects in a photo. And best of all, no ML experience needed. Just call these Cloud Vision and NLP APIs from your app and you're ready to go. So while these libraries can be useful in many situations, what if your machine learning needs don't fall into one of these categories? Well, Firebase machine learning has custom model serving and auto ML vision edge that enables you to create and deploy custom ML solutions on your users' devices. Cool. So for our expense tracker app, the text recognition is what allows us to do OCR. So we can use that in our app. So now that we have machine learning to extract text from the upload receipts, what's next? After we get the text back, we need to upload it to some secure environment. there will probably be a lot of extracted text, and we want this text to be processed quickly from anywhere in the world. But where should we put it? Cloud Firestore. Cloud Firestore is a good option. As a reminder, earlier we talked about storage, which we used to store the receipt images. Storage is used for storing big chunks of data like images, audio, and video. Cloud Firestore, on the other hand, is a NoSQL database where you can store data like strings, numbers, and whatever your app requires. Firebase is used more for structured data and that you might be changing often. So while our receipt images are stored in Firebase storage, the processed text that we get back from Firebase machine learning will be stored in Firestore. Very similar to storage, Firestore has security rules so clients can talk to the database directly, but you can still make sure you only get access to the documents they're supposed to see or modify. So let's dive in a bit deeper on how Cloud Firestore is structured and how to use it. It's a document model database, which means all of your data is stored in documents and collections. You can think of a document as something like a dictionary or a hash table. It has a key set of key value pairs, which we refer to as fields. And the values here could be a number of different things, anything from string to numbers to Boolean values to JSON like looking objects to arrays, etc. It can also be binary data as shown in this example. So here we have a document containing the fields we saw in the previous slide. Each of these documents is stored in a collection. Documents can't contain other documents, but they can point to other collections that contain other documents, which can point to other subcollections and so on. So in our example, each document will contain information about one uploaded receipt. Here are some examples of what that might look like. Each receipt document includes some values, including the user as identified by the user ID given in Firebase Auth, the date, the amount, the vendor, the item, and whether the user has verified these details yet or not. And all of these go into one collection, a collection containing all receipts. So with code, it looks something like this. First, we add a document using add doc method. And the first argument to the collection is the collection that we want to where we want all these documents to go in. In this case, we want the receipts collection to store all the receipts. Then we just simply give it the document as a JSON object with the fields that we wanted to add. Here we can also see, so we can add the UID of the user, the date, the amount, the vendor, the item, and whether it's verified or not. When the document is successfully added, we can do something with that, or we can also handle an error case if that happens. In Firebase Firestore, this is what it looks like. So once the data has been successfully added, you can go back to the Firebase console, go to the Cloud Firestore tab, and you can see your collection already added. And you can see here that every document has an ID, which is made up of a random string made by Firestore. I did not type that anywhere, this is the random string. I did not type this anywhere, and it automatically created. Now, this is the ID, the unique ID that can be used to reference to this exact document. Inside this document, you will see all the fields we put in when we called add doc. Okay, so now that we have added the extracted text for our expense tracking app into the database, how do we get that data out of the database in order to send to the user so we can ask them to verify the amount? Since we want to get not all of the receipts that exist in the collection, but only the specific user's receipt, we'll have to write a query. We'll use Firestore's query function with the first argument, with the query method. And here the first argument is again the collection which you want to query from here, which is the receipts collection. The other arguments for the query function will be our queries. And we can use the where clause, similar to how you'd use it in SQL, that takes a field to filter on, a comparison operator, and a value. In our case, we want to get all the receipts where the user ID equals the function's UUID parameter. We also want to get all the documents that the user hasn't verified. So we'll have another query where we can check for that. And with that query, we can call the getDocs function to get the documents that satisfy the query from the receipts collection. With what we get back, we can then loop through the documents and send the information to the user to verify. As a side note, in Firebase, we actually have two different database products. One is a cloud Firestore, and the other is a real-time database, which is the older database product. The main differences between the two is that the cloud Firestore is faster at reading and writing and has better querying capabilities, and real-time database is faster at writing. The reason for these differences is how data is stored in each. Firestore stores data in collections and documents, whereas real-time database stores it as a giant JSON tray. If you want to find out more about each of these differences and how they can help you, please take a look at the documentation linked below. So now that we have our extracted text by deploying functions that run the text recognition and machine learning, what comes next? We want to notify users when we have their values, and we can ask them to confirm. How do we do that? Let's send them a push notification using Cloud Firebase messaging to tell users their receipt amounts. Firebase Cloud Messaging is a cross-platform messaging solution that helps you reliably send messages at no cost. And it can deliver hundreds of billions of messages on a single day, and with most of them delivered less than 200 milliseconds. Our users are trying to upload receipts, probably using all kinds of different phones. Thankfully, we don't have to invent our own notification system for each phone, because cloud messaging can deliver notifications to anyone using Android, iOS, and even the web. Cloud messaging does not need to track what kind of devices you're using, and we don't need to set up different service calls to different devices. Firebase will automatically do that for us. Lastly, we are not limited to just reminding users to confirm our receipt amounts, and we can also use this feature to announce new features that we launch for the app. For example, if we add a chat functionality for users to chat with other users, or we allow group functionality where users can create a group and share expenses with each other. All of these features can now use the notification feature to let users notify them of anything. Okay, so if you look at the flow now, this is where we are. So we added a sign-in user using authentication. We allowed users to upload receipts using storage. We would run processing on these receipts on Cloud Functions, where we would use OCR from the Firebase machine learning algorithms to extract the text. The extracted text will be stored in Cloud Firestore, where we would call a Cloud function to send a notification using cloud messaging to the user. Once the user confirms that they have received the notification and the data looks good, we will store that again in the Cloud Firestore so that we can know that the data has been verified. Now that we have built the app, it is just sitting on our laptops or perhaps in GitHub. And now we've built this using mobile, example, Android or iOS, which is the most chosen platform for the particular app. And we'll eventually figure out how to put it on the Play Store or App Store. The last part is, if we additionally want to build it for the web, we can use Firebase Hosting to help us get it off our laptops and actually deploy it onto a website for people to use. So let's talk about Firebase Hosting. First and foremost, Firebase Hosting is a really easy way to host your web apps. All you have to do is install the Firebase command line tool and write a single command, Firebase deploy. From there, Firebase Hosting, Firebase Hosting provisions an HTTPS certificate, which guarantees security and deploys your assets to an origin server that will serve your content through a CDN, or a global CDN, or a global content delivery network. If for any case you want to roll back your app, let us say you shipped an error or there's something with the build, you can always roll it back from the Firebase console with just a click of a button. Firebase Hosting has a global CDN, which stands for Content Delivery Network or Content Distributed Network, And this means that there's a distributed set of servers holding your content. So whenever someone pulls up your page, the content is retrieved from a location as close to the user as possible. For example, if we didn't have a global CDN and only had one server in the US or India, someone halfway across the world trying to access our website might have to wait a bit for the page to load, which isn't a great experience. With a global CDN, we can always have another server closer to the user. So accessing our website will be faster because the place to the content is physically closer. Sometimes we'll have to update our website after having it deployed once before, whether it's because we changed some content, add new features, or for some other reason. When we do this, we can redeploy in Firebase hosting, and it's atomic, which means that all of the servers get updated with the new website and all the caches get purged. This way, the user is guaranteed to get the latest version. So there we have it. Our app is built. We've successfully built an app from beginning to the end with full functionality. We allow users to log in via authentication, upload receipts, which get stored in storage, trigger cloud functions to do OCR, which uses Firebase machine learning to extract details from the receipts, which then gets stored in our Firestore database. Next, we run some more functions based on the values being written to the Firestore to automatically send a cloud message to the user and have them confirm the receipt amount. We even put up a website so that users can start using it. We didn't have to write much code to accomplish all of this, and yet here we are. These are pretty much all the Firebase products that can help you build the app. And actually, in this case, cloud messaging is typically used to grow your app, that I tossed in as a bonus. And that's it. So now we have a fully functioning app that we can share with the users. Here are some of the Firebase resources that you can use. Our documentation is pretty comprehensive. We have a bunch of YouTube tutorials. Do check it out, and which will talk about each of these products in much detail. All the code that I showed you here is available on the documentation somewhere. We also have an official YouTube channel that comes with regular tutorials and code labs for these kind of things. And thanks for having me. I'm happy to take questions. Let me open my Zoom screen and see if we can get started. Okay, let's kick off the Q&A. So the first question I see is, can Firebase be useful for building data science apps? Yes, thanks Prasad for asking the question. Yes, 100%. Firebase can be extremely helpful for data science apps. Like I gave the demo here, you can use machine learning, you can use data science application as a backend and deploy it on Firebase hosting on Firebase. It all depends on what exact app you're building and what kind of use cases you have. If you're building apps that charts the data, allows users to run some analysis on their spreadsheets, or allows them to upload spreadsheets and do statistical analysis on those kind of things, all of that can be built in a very same way to the way I just showed on in the presentation. One thing to keep in mind is Firebase works very well with Google Cloud. So if you have any other Google Cloud products that you want to use, Firebase could be a great way to use them. So one of the classic example is like BigQuery. BigQuery is a data warehousing / querying solution for doing data science related tasks. And so you can use BigQuery right from Firebase, and that is how you can build your data science apps. Okay, I hope that answered your question. Let's go to the next one by Catherine. What are Unity and Flutter? Great questions. So Unity is a game development platform built by a third-party company, not by Google. It's a very popular platform for building games on Android, iOS, desktop, and I think even gaming consoles. So Firebase does have Unity support for some of the products, which means that if you're building a game in Unity that runs on desktop or runs on is built on using Unity, you can use tools like Firestore to do that. And what is Flutter? Flutter is Google's cross-platform development engine, app development engine, and allows you to build great looking apps using Flutter for Android, iOS, desktop, and the web. It's a substitute for rather than building one app for Android, one app for iOS, you just build it once. You build your UI code once, and then it cross compiles to different platforms, and then you can share your app on different platforms. The website for checking out Flutter is flutter.dev. Do check it out. Firebase works really well with Flutter. Both of them go well hand in hand. And it's using Firebase and Flutter is a very quick way to get started with a cross-platform app from the day one. Okay. Next question by Irnani. Can I create a use once auth? I mean, if I want to build an app to just explore a certain research and I wish to distribute some numbers and tokens for accessing it and answering questions, is that possible for auth? I believe it is possible. I think you can have your custom supports custom auth, and you can generate the tokens there and share that with your users. Yes, 100%. I'm sure that there's documentation online that you can take a look at. It should be able to support your use once auth. Next question is Nirmal by Nirmal. What is the storage limit on Firebase Cloud? So there's no storage limit on Firebase Cloud. It's a pay as you go, which means if you store a lot of data, you might have to end up paying. And the payment is not necessarily based on the storage you used. It's also based on the input and output bandwidth. So if you keep a file but nobody accesses it, there's very little cost for that. But if you have a file which is being streamed by millions of users around the world constantly, there's a lot of output like inbound and outbound data. In that case, that might be some limits there. So yeah, there's no limit. Like I said, it scales seamlessly with your app. So you don't have to worry about whether I will run out of disk quote or anything. You can just keep uploading data. And you can check out the pricing on the Firebase storage page to see how that fits with your data needs. Is there any limit on Firebase account? There's no limit on the Firebase account. Like I said, there are few services that obviously depend on like for example, data store and Firestore and functions. Firebase has a generic free tier. And within the free tier, yes, there are limits on how much compute you can use or how much data you can upload. But it also has a pay tier and then the pay as you go model where there's no limits, like a regular cloud offering. How is a custom ML solution charged? Great question, Mayank. So the custom ML solution works primarily so the custom ML solution is primarily designed to work on client side, which means that you upload a TensorFlow model or any other model that can also be converted to a TensorFlow model. You upload it on the Firebase console, and then the Firebase ML SDKs make sure that the model is available on the device, on the user's device. And there's absolutely no charge for using custom ML, which basically means what you're doing is you're uploading your own model, and Firebase is using its servers to keep track of delivering that model to the user's devices, updating it when you put a new version. So there's no charge for custom ML. The other half of that solution was AutoML Vision Edge. AutoML Vision Edge is a general purpose an image classification model service where you can upload your own images, tell the model to learn certain kinds of classifications, right? So for example, let us say you're building a flower identification app. So you can upload pictures of flowers. You can tell the model, hey, these are the flowers. It can train a new model, and then you can call the APIs to detect the flower in any other image in the future. And so there's the pricing for that. I don't know the pricing for that. You can go check it out. But obviously there's pricing because the machine learning training, the model building, the model serving, all of that is happening on the cloud. So you can check the pricing for that. But the custom ML solution, like I said, where all you're doing is uploading your TensorFlow-like model and then using that in your TensorFlow model and then using that in your devices, there's no charge. How do you deploy machine learning recommendation engine in one app using Firebase? Question by Harendra. I'm using BigQuery. machine learning recommendation engine in one app using Firebase. I'm using BigQuery. So I think what you'll need to do here is you'll need to build a recommendation engine on top of BigQuery where your data is being stored. There is no off-the-shelf machine learning service that I know in Google or in Firebase that can help you do it. So your app options are sort of limited in terms of like what are open in terms of what you want to use here. You can use third-party tools. You can build your own recommendation engine using TensorFlow or PyTorch or any of those new machine learning frameworks. You can deploy it on Google Cloud. Now, so once you have a model, there are multiple options, right? One option, as Mayank suggested, is the custom ML solution, where you put a TensorFlow-like model and the model runs on the device. For recommendation engine, that might not be the best case. You need to go through a lot of data in the backend. And so in this case, you deploy it on your servers, either as a custom solution or on GCP, which can then be used within Firebase. And so here, like I said, a Firebase app can use any backend service. So either you host that backend service in any cloud, in Google Cloud or anywhere with that model serving, or use some third-party service that provides machine learning recommendation engine. Hope that answers your question. Next question. How can e-portfolios assessment be done using Firebase Web? I need help in development of this. I'm not sure what e-portfolios assessment means. Feel free to add like more detail and I can get back to you. Last question, can TensorFlow object detection API be used? Yes, it can be used. I think we have in Firebase machine learning, we do support that as an API, which means that you don't have to do any hard work in getting that to run. Experience is very easy. If you want your custom image detection models, for example, you can always use the custom ML solution, upload your model on Firebase storage, and then we'll serve that model in your apps so that you can use it directly within your apps. Okay, also I should have clicked answer live, but I think we have gone through all the questions and I think that should be it. If there are any questions, feel free to ask. I do IT. Okay, there's a new question. Let me just mark the other ones at live. I do IT for a very small school, basically no budget for app development. We want to build a notify a very small set of parents about invoicing and school activities. Do you have any easy to follow tutorial for someone like myself who wants to try app development with Firebase? It's a great question, Francisco, and I think Firebase for you is going to be extremely useful and perfect for your use case. As far as tutorials go, I would say check out the Firebase website. We have a lot of code labs where you go through like a dedicated set of tutorials, like a build an app similarly to how we did in the webinar, but more hands-on, where you can run code on your laptop and deploy stuff from your laptop or your computer, as it's going to be very useful. For something like I said, the Firebase free tier is very generous. In most cases, you should be able to serve your needs, specifically the stuff that you have here with the free tier, but feel free to check it out. And yeah, let me know. Cool. I think that are all the questions. If there are any more questions, please feel free to ask. Thank you, everyone.